Absorption of iron depends on the physiological requirements of the body. Iron absorption takes place predominantly in the duodenum and upper jejunum. For the treatment of iron deficiency, oral iron supplementation is used, which include ferrous and ferric forms. Now let us look at the difference in the absorption and metabolism of ferrous and ferric forms of iron preparations. Ferrous iron is absorbed via three main mechanisms: active absorption via the divalent metal transporter, or DMT1, passive transcellular diffusion through the gut membrane, paracellular passive diffusion through enterocytes. Due to the uncontrolled absorption, free ferrous iron is oxidized in the lumen of the gut or within the mucosa, causing the release of activated hydroxyl radicals which attack the gut wall. This produces a range of gastrointestinal symptoms such as nausea, vomiting, and diarrhea. The ferrous iron that passes into the bloodstream gets converted to ferric iron via hephaestin and is transported via transferrin to target organs. However, the high serum iron concentration from the uncontrolled uptake of ferrous iron leads to the saturation of transporter protein transferrin and increased production of non-transferrin-bound iron. This non-transferrin-bound iron is taken up in an unregulated manner by the cells, which paves way to oxidative stress via lipid peroxidation, membrane disruption, enzyme inactivation, and DNA strand breakage. This results in damage to organs such as liver, heart, and kidneys. Maltofer is a bioavailable form of ferric iron that is bound to a polymaltose complex. Ferric iron of maltofer must first be converted to ferrous iron prior to absorption. This conversion is mediated by duodenal cytochrome B. The ferrous iron from maltofer is then absorbed into enterocytes via a controlled active mechanism through divalent metal transporter 1, or DMT1. Maltofer does not cross the membrane via passive diffusion because of its large molecular weight. The low concentration of ferrous iron from maltofer then enters the bloodstream, where it gets converted to ferric iron and is transported via transferring. Due to the controlled uptake of iron, maltofer is associated with a lower production of non-transferrin-bound iron, or NTBI, and hence causes less oxidative stress to tissues. Compared to ferrous salts, maltofer is associated with a better safety profile and fewer gastrointestinal side effects such as nausea, vomiting, and diarrhea. Maltofer, iron with a difference.